Today we're going to look at 4.1, which is going to be graphing quadratics using standard form, which is how we did this in Algebra 1. Alright, so first we need to know what standard form is. So standard form is y equals ax squared plus bx plus c. Alright, so we need to have that memorized. That's standard form. The other thing that we need to make sure that we know is how to find the vertex. So the vertex is the minimum or the maximum of the parabola. Alright, so you find this point or this point, depending upon which way it opens, using this formula, x equals the opposite of b over 2a. You can see where you get b from and where you get a from. So these are two things that you need to have memorized for our test and at least be familiar with for our notes tomorrow. So let's look at an example. Let's graph, and we'll just graph on our notebook paper. We can use graph paper tomorrow. Y equals 3x squared minus 6x plus 4. Alright, so we're going to graph this function. So using standard form. So step 1 is to identify what a, b, and c are. So a is equal to 3, b is equal to negative 6, and c is equal to 4. When we get a little bit better, we might not have to do that part, but this is a good way to start. Alright, step 1 is to find the vertex. That's always our starting point when we're graphing using standard form. So x is equal to the opposite of b over 2 times a. So we substitute in our values, so negative from the negative b, and then a negative 6. So it's the opposite of b, which would be a positive 6, because if you look above, b is negative 6, the opposite of b is positive 6. So hopefully that makes sense. And then 2 times 3. So notice that we just took this 3, plugged it in, 2 times 3, so we're going to get 6 over 6, which equals 1. Alright, so that's the beginning of our graph. Step 2 is to make a t-chart. So we're going to have x, y, the 1 goes in the middle, the vertex goes in the middle, you pick 2 smaller and 2 bigger. Very similar to how we did absolute value, kind of like how we pick the vertex in the middle and then we pick smaller and bigger. So now we're going to take each one of these x values and we're going to plug them into the original equation. So when I plug in negative 1, this is going to be 3 times negative 1 squared minus 6 times negative 1 plus 4. So this will be 3 times negative 1 squared minus 6 times negative 1 plus 4. So you just plug that number in and you basically calculate. So 3 plus 6 is 9 plus 4 is 13. And then we take the 0 and we take the 0 and we plug it in. 3 times 0 squared minus 6 times 0 plus 4 is 4. And then we plug the 1 in. 3 times 1 squared is 3 minus 6 times 1. So that would be negative 3 plus 4, which would be 1. And then we plug in 2. We're going to take 3 times 2 squared. So 2 squared is 4 times 3 is 12. Minus 6 times 2, which is negative 12, so that makes 0. So we're left with 4 again. Notice that it's symmetrical again. This one will be 13. So then step 3 is to graph. So we're going to start with negative 1, so go left 1, up 13, 6, 7, 8, 9, 10, 11, 12, 13. Alright, 0, 4, over 0, up 1, 2, 3, 4, 1, 1, over 1, up 1, and then 3, 13. Oh, sorry, 2, 4, and then 3, 13. So it makes this U shape, so make sure that you make it a U and not a V, and this is the parabola. Conveniently enough, a lot of times the directions will say to draw the axis of symmetry, which is exactly the same as the vertex. Remember that vertical red line is x equals 1. A vertical line has an equation of x equals, and then x equals 1. Right? So the last part here, we have one of the questions, or a few of the questions are going to ask us about the max or the min. And so you can look at a problem and know whether it's going to have a max or a min. In our example here, this tip, this vertex, is a minimum because it's the smallest point on the graph. Anytime A is positive, that means the graph is going to open up, so you're going to have a minimum. So when A is positive, the graph is going to open up, and that means that the vertex will be a minimum. When A is negative, that means that the graph will open upside down, so it'll open downward, and the vertex will be a maximum because it's the highest point on the graph. All right, and if we know those things, then we're pretty much set to go, and we'll practice some more tomorrow in class.